We are going to learn how to calculate centroids for different types of figures, and I'm going to illustrate for two complicated figures how to do the addition method and also the subtraction method. The first thing to remember are the formulas that we are going to have. For x with a little bar on top of it, that means the x value for the centroid of the entire figure, and the y value for the entire figure as well. The way to calculate them is going to be by having the sum of the individual centroids multiplied by the areas and then divided by the sum of the areas. I'm going to work on each of the figures now. In the first case, we're going to be using the addition method. For this, I will label the little rectangle in the bottom as A, and the triangle on the top of the figure is going to be B. I have pre-filled the chart that you're going to be needing to do all of the calculations. As you remember, the first thing to do is to find the centroid. To find the x value of the centroid of A, I am going to use the base, which is 6, divided by 2, and that gives me a value for 3. In order to get the y value for the centroid, I'm going to now be using the height, which is 10, and I will divide it by 2, and that gives me a value of 5. To work on figure B or the triangle, I have to divide the base and the height by 3. So I will take the value for 6, again, is the same base as the rectangle, and I'm going to divide it by 3. That gives me a value of 2. To get the height, the entire height is 13, but I'm only interested in the height of B or the triangle, that is a value of 3. I divide 3 by 3 and get 1. But I need to realize that the centroid of the figure triangle is actually all the way over here. That means that I need to add to this the value of the other part of the height of the rectangle. That is why I am using in this case a value of 11. Then we should find the value for the areas. The area of the rectangle is base times height, or 10 by 6. That gives me a value of 60. And then to calculate the area of a triangle is base times height divided by 2. That gives me a value of 9. As you remember, we need to have the addition of all the areas, and I can do that already now. For the bottom part, I can just copy the top part because the areas are going to be the same. Then my formula tells me to multiply the x value by the areas and also the y value by the areas. I do the multiplication for x and area and get 180. 9 times 2 is 18. And I'm also multiplying the y's times the areas. So I get 5 times 60, which is 300. I get 11 times 9, giving me a value for 99. And then I will add both cases. Remember that we need to have the sum of the multiplications. Then I can work on both of my formulas, the formula for A, and then I will put the addition that I already have, which is 198 over 69, which is the addition of the areas, and I will get the value. I will do the same thing. I will have the addition of the areas multiplied by y, and then the answer is going to be 4.5. After I do this, I can calculate that the centroid is going to be located at 2.86, 4.5 centimeters. For the second figure, I'm going to be using the subtraction method. As you can see, we kind of have like a little rectangle, which I'm going to be calling A, and then the top part I'm going to call B, and that seems to be like a little square that is missing from a rectangle. So the first thing to do is that we're going to calculate the centroids for both figures. The centroid for figure A will be in the middle of the 12. That gives me a value of 6. The centroid value for y in the same figure or A is going to be 7. Now to calculate the centroid on the figure B, which is actually a little square and has two sides, we can see that the centroid will be on one towards the right and one going up. But I need to calculate this with the entire distance. I'm going to calculate the entire distance from x and the entire distance from y. That means I'm going to be adding to the 12 in y and to this value of 10 in the value for x. So I get 11 in the case of x, and I will get 13 for y. After I do this, I'm going to calculate the values for the areas. In the case of the area of A, I'm going to multiply 12 times 14, and I get 168. But remember that now we're going to be removing the area of B. So the area of B is 2 times 2 or 4, but that value is going to be negative all the time. I have the addition of the areas, and I can just go ahead and copy those values all the way to here. The next step is to multiply the x values by the areas and the y values by the areas, and again have our addition so that we can complete the formulas. When I get the value of the centroid for the entire figure for x, we're going to get the multiplication that I obtain here. I bring it down all the way to my formula, and I'm going to be doing the same thing for y. I will get the sum of y and area multiplied, and then I will divide it by the sum of the areas that I previously obtained. This gives me a centroid location of 5.88 centimeters in x and 6.85 centimeters in y.